Well, hello everybody, and welcome to Chapter 3, 3 Claims, 4 Validities, Interrogation Tools. This really is the chapter that sets up the way that the author talks about research. This is an extremely important chapter, and so I really want you to take your time listening to the lecture, reading the textbook. There are a lot of terms, so this is definitely a chapter I would suggest reading a couple of times and going through and working through the activities. So we're going to talk about variables, 3 claims, interrogating the 3 claims using the 4 big validities, and prioritizing validities. And you'll see that throughout the chapters, we keep coming back to the 3 claims and 4 validities concept again and again. So this is a real important chapter to understand. We will start with the term variables. A variable, when you do a research study, is any class or category of an event, a situation, a behavior, a characteristic that varies. And that's the key, right? Variables vary. And what does vary mean? It means it can be different. So your variable has to have at least 2 values, and we call those 2 values levels. If it only can take on 1 value, then we would call it a constant, not a variable. So, in this example, a sample of registered voters was surveyed. Each voter was first asked to name his or her gender, and the choices were male or female, and then to name the candidate for whom he or she planned to vote, Doe, Jones, or Smith. And the purpose was to explore gender differences in voting preferences. So if I were to ask you what is one variable in this study, you would hopefully say gender. And what were the levels, male or female? And another variable in this study would be candidate for whom he or she planned to vote. And the levels are Doe, Jones, or Smith. And this does give us a good example, not only what a variable is, but in the way that we measure variables, which we will talk about as we go through research methods and designing studies, because certainly one of the variable that has evolved in terms of how we might measure it would be gender, whereas years ago it would be maybe just a simple male or female. Now it's more common to see male, female, or other. Or you could put gender on a continuum from male to female, and you sort of mark where you are along the continuum. So as a research scientist, your job is to decide how you're going to measure each variable. And there are obviously pros and cons to each way that you decide to measure a variable. There's not necessarily a right or wrong way, and we'll be talking about this throughout the class. But back to variables. A variable is anything that you are measuring that can take on at least 2 values. Variables can either be measured or manipulated. A measured variable is something that you observe and record. All you're doing is measuring whatever that variable is. Whereas a manipulated variable is one that you manipulate, one that you control. Some variables can only be measured, not manipulated, right? Can you think of some variables that can only be measured? Well, if you think about, gender, right? All we can do is ask someone, what is your gender? And we record what their answer is. We can't manipulate or change that in our research study. If you're doing a study on comparing people diagnosed with schizophrenia compared to people who are not diagnosed with schizophrenia, whether or not they have schizophrenia is a measured variable. I can't manipulate it. All I do is ask the question and measure or observe and record what they say. A manipulated variable is something you can manipulate. So if I want to do a study on how does hours of sleep control your test score, well, hours of sleep is something I can manipulate. Or if I want to try a new medication and see if giving someone a new medication for depression compared to Prozac, which is kind of a older, more reliable medication for depression. So I want to compare, and I can manipulate that. I can say, well, this group gets the new medication and this group gets Prozac. Or maybe I want to manipulate the amount of the medication. Does 5 milligrams or 10 milligrams or 20 milligrams of the medication work better? That's, again, something I can manipulate. And there are some variables that you can either manipulate or measure. So you have to think about what you're studying, and is it something that you as a researcher can manipulate or not? Because it's not possible, right? You can't change whether or not someone was diagnosed with schizophrenia, or it's not ethical, right? If I want to do a study on do children whose parents are divorced show more signs of anxiety than children whose parents are married? Well, divorced versus married is a variable, but I can't ethically manipulate that. I can't say, welcome to my research study. Okay, I'm randomly assigning these couples to get divorced, and these couples, you must stay married, and then we're going to measure that effect on your children. That is just not ethical. So that's, again, a variable that I would just have to measure. A key term that we'll come back to over and over again in this class is what we call operational definitions. As researchers, we are trying to define theoretical constructs or theoretical ideas that are stated in a concrete, observable way, a very scientific way. So if you were talking about the operational definition of terms in sports, which is pretty funny because I will tell you I don't know very much about sports at all. But for example, what counts as a basket in basketball? And probably one of you should be giving this lecture instead of me. But there are specific rules that count for it to actually count as a basket when you're playing basketball, and you get the points for a basket. And I don't know what those rules are. I'm guessing you can't just stand right under the basketball hoop and throw the basketball up so it goes up through the basketball hoop and then right back down. It's like how I could make a basket. That you wouldn't get points. Even though that ball did go through the basket, it's not officially considered a basket in a professional game of basketball, right? I know there are lines around the court, and you have to shoot that basket from within those lines, right? And if you are somewhere else on the court, then it doesn't count as a basket, right? Or if you're in the stands, I don't know. But there are specific rules, and they say if the person throws the ball within the lines from a certain area, I don't know all the rest of the rules, that counts as a basket. And if not, even if the ball does go through the hoop, it's not a basket. And that's the key to our research in psychology, is that we have to define psychological terms in an observable scientific way. And we could try this right now. We have a bunch of people in our class, and you're watching this video at different times. And if I said to you all, who's tired? Let's say I sent out a class survey and I asked you to write down if you're tired or not, and think to yourself, raise your hand if you're tired. What do you think would happen? Probably a lot of you would raise your hands. And then my question would be, would every single one of you who says that you're tired right now be talking about the same thing, be talking about the same level of tiredness, the kind of an objective, similar idea of what tired is? And the answer would probably be no, because although we all know what the word tired means, you've known that since you were probably 2 years old, we all understand the subjective idea of what it means to be tired. Being tired, there are different levels, there are different reasons, and that's just too broad for us to do a research study on this variable of who's tired. So in fact, we would have to turn our conceptual definition of tired, conceptual meaning you all know what tired means, into an operational definition. An operational definition means you and I are going to come up for our research study with a very objective way that we are going to measure how we're going to consider whether someone is tired or not tired. So I could come up with a number of different ways to do that. The first I could say is, if you're going to be tired in our research study, then you will have slept less than 5 hours the night before. If you've slept 5 or more hours, you're not tired. If you've slept less than 5 hours the night before, you are tired. Okay, that is an operational definition. It is objective, it is clear, tells you exactly, we know exactly whether or not people would fit into that definition of tired. And so now if I said to you, given that definition, that operational definition, are you tired? Raise your hand, right? Or think about that to yourself. I'm guessing not everybody who originally said they were tired would now fit into that operational definition of who's tired, right? You're only tired in my research study if you slept less than 5 hours the night before. Now, of course, that's not a perfect definition, right? Because there are some people who might not need very much sleep, and even though they slept less than 5 hours, they're still not tired. There are some people who slept 8 or 9 hours last night, and they still do feel tired. So we could think of other definitions. Operational definitions, they must be objective and clear and not at all subjective. So we could say, I'm going to send a research assistant to your house, or put a little camera in your house if you agree to be in my research study. And in this hour that you're watching the video, if you yawn more than 3 times, I'm going to consider that you're tired. And if you yawn less than 3 times, you're not tired. So number of yawns is how I might operationally define tired. And so I would get the videos from everybody's house and I'd count up how many people were tired, the ones that yawned more than 3 times, and how many people are not tired, the ones who yawned less than 3 times. I could also do a questionnaire. On a scale of 1 to 10, how tired are you? And just have you circle what you are. That is another way to operationally define tired. I could do something more scientific and put electrodes on your head and measure your brain waves. And we know what sleepy looking brain waves look like. And so I could use that as my measure of tired. None of them are perfect, right? None of these are perfect measures, but we have to do our best to take a conceptual definition of who's tired and that idea, that subjective idea of who's tired, into something that can be measured in an objective way. And so here's some examples from your book. The conceptual variable of car ownership. We're interested in people who own cars and how they operationally defined car ownership. This is just one possibility. They asked people to circle, I own a car, or I do not own a car on their questionnaire. So the variable is car ownership. There were 2 levels, own a car or not. And in this case, it's measured, right? I'm measuring it. I'm just asking them and observing what their answer is, right? I'm not giving people a car. That would be manipulating it. Here's a car. You own it now. And take away people's cars for other people. Expressing gratitude to a romantic partner. Again, that's the variable I'm interested in studying. My operational definition in this case is researchers asked people in relationships the extent to which they agree with items such as, I tell my partner often that he or she is the best, right? And they would circle agree or disagree. So this is on a questionnaire. And this had 7 levels. Oh, so not just agree or disagree, 7 levels. 1 strongly disagree to 7 strongly agree. We call that a Likert scale. And so you measure how someone feels about expressing gratitude to their romantic partner in this way. Again, there are other ways you could measure this, right? You could measure this observationally. I could, again, videotape or have a research assistant observe people in a laboratory, but this is one way. And again, this is a measured variable. Type of story told about a scientist. So researchers could assign participants to read stories about Einstein and Curie, which related either to their work, struggles, or their achievements. Okay, and so the idea here is that depending on what type of story someone is told about a scientist or a researcher, either one that is related to how much they struggled to make their discoveries, or just focused on their achievements, look at all the amazing things they did, would that affect something? And we don't know what the end of this research study is about, but they, in this case, have 2 levels. They have 2 different stories. They have a story about a scientist's struggle and a story about a scientist's achievements. And in this case, it's manipulated because people would come into your research study, and they would probably randomly be given either the story about struggles or the story about achievements. What time children eat dinner? This could be measured by using a daily food diary. Researchers had children write down what time they eat dinner every evening. And then they divided those children into 2 groups, those who ate dinner between 2 and 8 p.m. and those who ate dinner after 8 p.m. Again, this is a measured variable. Okay, so we have to go from the idea of what we want to study to some kind of operational definition. And there are many possibilities. These are just one, but there are many ways you can measure these variables. And as psychologists in real life, operational definitions are even more difficult because you're trying to come up with operational definitions for anxiety, for depression, for stress, for self-esteem. How do we measure those concepts in a very objective way? It's not that easy. So as psychologists, as we work on building our research studies, this is one of the first challenges we have, is how to take these very subjective ideas like your level of self-esteem and then turn that into something that we can measure in an objective way. All right, moving from variables to claims. These 3 claims that the author of our book talks about through the entire book. A claim is basically an argument someone is trying to make. And we use data to test and refine these theories or claims, or the arguments that we're trying to make, the ideas we're trying to test. All right, so what are the 3 claims? The first is a frequency claim. And a frequency claim describes the rate of a single variable. Okay? Frequency claims involve one measured variable, and this is percentages or X out of X people agree with this statement, etc. So anytime you see something like, I don't know, 70% of college students are satisfied with their college experience, that's a frequency claim. 2 out of 5 dentists like a particular type of toothpaste. That's a frequency claim. Anytime you're talking about the frequency of something occurring, it's a frequency claim. Here we go. 2 out of 5 Americans say they worry every day. Just 15% of Americans smoke. 72% of the world smiled yesterday. Oh, isn't that sweet? 4 in 10 teens admit to texting when driving. Ooh, right? Do you see an issue with this frequency claim? Only 4 in 10 admit to texting while driving. How many actually do it? I don't want to know. Please don't text and drive, right? It's very dangerous. All right. So that's a frequency claim when you have some number out of some number or a percentage, kind of a simple one to figure out. Now, what about an association claim? An association claim argues that one level of a variable is likely to be associated with a particular level of another variable. So an association claim involves at least two measured variables. There's the key. The variables are not manipulated, and we use words in an association claim, things like these two variables are correlated, these two variables are associated, these two variables are related. Those are the types of words you're looking for in an association claim. They're not always there. Sometimes they're harder to figure out just from a headline, but people with higher incomes spend less time socializing. And so we're just associating, we measure what someone's income is. So we'd ask, what's your income? And then how much time do you spend socializing? And then we're finding that the people with the higher incomes spend less time socializing. Romantic partners who express gratitude are 3 times more likely to stay together. People who multitask the most are the worst at it. And a late dinner is not linked to childhood obesity. So we would ask, what time do you eat dinner? And weigh your child and see if there's a correlation or an association between those things. So for an association claim, you have 2 variables and they're both measured. Again, it may be hard to see that from these headlines. That's okay. You would want to read deeper into the research article to see what they were doing. Association claims and the data are shown with a scatter plot. And here's an example of a scatter plot where you have 2 variables. In this case, we have family income in $1,000 and students' grade average. And so we're looking at the association between a family's income and a student's average grade. And so we have one of the variables on this x-axis. In this case, it's family income. And the other variable on the y-axis, this is the student's average grade. And each dot on this graph is one person in our study. And you can see person A here, their family makes $31,000. And their average grade on a test, let's say, is 72. And so that's this dot here. The family makes $31,000 and 72 is the average grade, and there's their point on the graph. And we could go down here to person N. Their family makes $174,000 and their average grade is a 95. So $174,000 and their average grade is a 95. That's that person right here. And everybody else is plotted on this scatter plot. And you can look for an association by looking at these dots on this graph. Is there anything that you can see? And we're looking for a pattern. And hopefully you're seeing the pattern that as family income goes up, students' average grade tends to go up. And as family income is lower, students' average grade is lower. We're looking at this relationship. Now, when we look at associations, when we look at these association claims, this doesn't mean that's the case for everyone. There are always exceptions to this, right? We talk about the weight of the evidence. Is it possible that somebody's family has a lower income and they have very high average grades? Of course. And is it possible that someone's family has higher income and low average grades? Of course. But we're looking for this general pattern or the general trend in our data. And we will have a whole chapter where we'll talk about associations or what we call correlations. But just as a kind of brief description here, There are two main types of correlations, positive and negative. When you use a scatter plot, a positive correlation looks like an upward sloping line from left to right. This is a positive correlation. And in this case, we're looking at the variables of temperature outside and amount of beer sold. We're looking at the relationship or the correlation between beer sales and temperature. And so these are both measured variables. We measure what's the temperature outside and how much beer is sold at a particular store. And what we find is that the lower the temperature, the less beer is sold. The higher the temperature, the more beer is sold. We have this general upward trend from left to right, and we would call this a positive correlation. And what we mean in that by positive correlation is that the two variables work together, meaning if you are low on one variable, you tend to be low on the other, right? When temperature is low, amount of beer sales are low. And when temperature is high, amount of beer sales are high. That's a positive correlation. A negative correlation on a scatter plot looks like this, a downward sloping line from left to right. And in this case, we're looking at the relationship between temperature and coffee sales. And when you have a negative correlation, you have this downward sloping line, you basically have the two variables working in opposite directions, which means when temperature is low, so it's pretty cold outside, amount of coffee sold is high. And when the temperature is high, coffee sales are low. And that would be a negative correlation. And again, we'll talk more about this in our whole chapter on correlations. Of course, it is possible to have a zero correlation or a zero association, meaning perhaps as a researcher, I thought that time of dinner would be related to childhood weight. But once I collected the data, I can see I have no pattern here. I have no relationship. This is just a random amount of dots all over this chart. People can eat dinner early and they can be less obese or more obese. Children can eat dinner late and be less obese or more obese. There's no relationship. So a zero association basically just looks like a random array of dots on the scatter plot. Now, you can make predictions based on associations. Association claims can be useful because they help us make predictions. The stronger the association between the two variables, the more accurate your prediction will be. And when we talk about stronger associations, we mean that here's our, we call this a regression line or the line of best fit through all of our data points. So here's all our data points, and then this is a mathematical equation that basically gives us the line that is the best fitting line through our data points, meaning that it's the closest to all the data points. And if those data points are all very close to that line of best fit, that's a very strong association. And as these data points move farther away from the line of best fit, then that's a weaker relationship. The stronger the association between the variables, the more accurate your prediction will be. And from both positive and negative associations, you can make predictions, right? I could look at this, sorry guys, here we go. And I could make a prediction that if the temperature was 90 degrees, I could predict how much coffee would be sold, even if it's a negative correlation. Or if it's a positive correlation, if it's 90 degrees, I could predict how much beer is going to be sold. I just can't make predictions when we have a zero association. All right, the last claim that we'll talk about is called a causal claim. This is again where you have two variables, but you're trying to see which one causes the other. In a causal claim, you have one manipulated variable and one measured variable. Remember, for association variables, Both variables are measured. So we have a manipulated variable, and our manipulated variable is called the independent variable, and we abbreviate that IV. And the measured variable is the dependent variable, and we manipulate that as the DV. So what do I mean by that? Experiments, you get a causal claim when you do a true experiment, and we're going to be talking about that later in the class. But when you do an experiment, you're actually able to estimate the extent to which the independent variable causes a change in the dependent variable. And so in a causal claim, you're really trying to understand something about cause and effect. And cause, the causal variable, like I said, is the independent variable, or the IV. This is also the causal variable, the IV, that's the one you manipulate. And as a researcher, I choose its values. The effect variable is the dependent variable, or the DV. This is the one that you measure, and we measure it in relation to the independent variable. So for example, if I was doing a research study where I was manipulating amount of sleep college students get the night before a test, and I'm going to measure their test scores. And so I have, let's say, 100 students who volunteer to be in my research study, and I randomly put 50 of them in a group, and I keep them up all night so they don't get any sleep. And the other 50 are in my 8 hours of sleep group. They get to sleep 8 hours. Then I wake everybody up in the morning. Well, these people hadn't been sleeping, but I just tell them, okay, here we go. And I give everyone the same test. And then I measure who did better on the test, the group that slept for 0 hours or the group that slept for 8 hours. In that case, the independent variable, or the causal variable, is hours of sleep. I chose its values. Remember, I chose 0 hours of sleep or 8 hours of sleep. I could have chose 0 hours of sleep, 4 hours of sleep group, and an 8 hours of sleep group. I'm choosing that completely. That's up to me. The dependent variable, or the effect, this is test scores. And you can think of it that I think that test scores are dependent on the amount of sleep that the person got. The dependent variable is dependent on the independent variable. And this is what I measure, because I give everyone a test and then I just grade it. I don't do any manipulating. That would be unethical. I just measure how many test questions they got right or wrong. So for example, does type of class, online versus in-person, influence students' test scores? So you might want to pause this for a second and see if you can figure out the independent variable, the levels, and the dependent variable. And then when you're ready, start it up again, because I'll give you the answer. So the independent variable here would be type of class. That's what I'm manipulating. The levels are online versus in-person, and I'm choosing those levels, right? I could have online versus hybrid versus in-person, but I've picked online compared to in-person. And the dependent variable, what am I measuring? Test scores. Okay. This is a very important idea, the independent variable and the dependent variable, that we'll be coming back to throughout this class and in other classes as you go through other psychology classes. I have this chart here. You do not need to memorize this chart, but this just lets you know, as researchers and scientists, I think they like to use big words to try to maybe make people feel smarter or something. And so when we're talking about the independent variable and you're reading other research articles, there are many words for independent variable. It can be also called the explanatory variable, or the treatment variable, or the predictor variable, or the regressor. All of those mean independent variable. So if you're reading someone's research article and you see predictor variable, Well, I have this as a little kind of cheat sheet for you to know they mean independent variable. And the dependent variable can also be called the response variable, the outcome variable, the predicted variable, or the regressand. So again, this is just kind of for you to have as you're reading articles. Might help you if you come across one of these words. Let's see, practice makes perfect, IVs and DVs. Maybe you want to pause this here and figure out if you can find the independent variable and the dependent variable for each of these studies. Just write them down and then unpause this and I'll give you the answers. So here we go. You want to test a new drug that prevents sneezing in people allergic to grass. The independent variable would be the drug, and the dependent variable would be sneezes. We'd be counting sneezes. And in terms of the levels, we might compare a new drug to an older drug, like to Benadryl or Zyrtec or something else. I haven't written that there, but the levels would be the two groups I'm comparing. A soap manufacturer wants to show that their detergent works better to remove tough stains. Our independent variable would be the type of detergent. And again, we might compare the new detergent to an old detergent like Tide or All or something like that. And the dependent variable would be removal of tough stains. And we have to figure out an operational definition. How are we going to measure stain removal? And a florist wants to see if their plant food will extend the life of cut flowers so that they last longer. So the independent variable here would be the type of plant food. And again, maybe we'd compare their plant food to just plain water, or their plant food compared to, I don't know, that little stuff that comes in the little white packets when you buy cut flowers from a florist. And then the dependent variable would be how long the flowers live. So hopefully that's starting to make sense. When you do a true experiment and have an independent variable and a dependent variable, you're making a causal claim, and a causal claim means that you are able to say that a change in the independent variable causes a change in the dependent variable. So only when you do an experiment and you manipulate the independent variable and measure the dependent variable can you say anything about cause and effect. Okay? And we'll talk a lot about how you design a true experiment, but again, you need an independent variable that you manipulate. And in this case, this was children who were randomly assigned to take keyboard lessons, voice lessons, drama lessons, or no lessons. So I'm manipulating the type of lesson. And then the dependent variable, what I'm measuring is an increase in full scale IQ. So an increase in IQ. I'm wondering, does taking some kind of lesson increase children's IQ? And in this case, they did find that to be the case. And one of the other keys, and we'll talk more about this as we get to the experiment chapter in our book, is that not only do you have to have an independent variable and a dependent variable, but you have to randomly assign participants to be in any of these groups. Meaning, you wouldn't just take a group of people who are already taking keyboard lessons and already taking voice lessons and already taking drama lessons and already taking no lessons and then measure their IQ. In that case, that would be an association claim because I'm just measuring what type of lesson do you take and their IQ. What I have to do is take a group of people who maybe aren't taking any kind of lessons. Maybe I have 100 children, and then I randomly put 25 into keyboard lessons, and I randomly put 25 into taking voice lessons, and 25 into drama lessons, and 25 into no lessons. And this is a random assignment. Each participant has an equal chance of being in any group. So I might take all 100 names and then pull out randomly 25 names to be in each group. And that is key, and we'll talk about why that is, but basically it eliminates any potential confounds, any potential alternative explanations as to the explanation of our results, right? If we didn't do that, if we just took people who were already taking music lessons, keyboard or voice, and we found they have higher IQs, well, it might be because of the keyboard and voice lessons, or it might be because, I don't know, something else about the parenting style of people who sign their children up for music lessons, or listening to more music in the household. There's lots of potential explanations. So that's why we need to manipulate the independent variable and randomly assign people to groups. The verbs for association and causal claims are here. And again, you can just take a look at them. For association, we're talking about is associated with, is correlated with, goes with. All we can say is these two variables are related. Whereas when you're using a causal claim, you're looking for words maybe in the headlines and in the writing that say causes, affects, changes, makes something happen, increases something. You're more able to say one thing causes another thing to change. All right. We're going to take a break right here, and we'll finish this chapter in the second lecture.